This video will explain how to determine the horizontal shift or phase shift and the vertical shift for the sine function that will model the passenger height for the London Eye Ferris wheel. First of all, let's graph the function that we have with the correct a value and the correct k value. We determined that the a value from the minds on of this activity was 67.5 and the k value was 12. There's the sine function for 67.5 sine of 12x. As you can see, we need to shift it up a fair bit and a little bit over so that it models the passenger height. Now, how much do we need to shift it up and how far over does it need to be moved? Let's start with the horizontal shift. To be able to determine both shifts, we have to be able to pick out one cycle of the sine function in our data. The sine function begins, goes to a max, goes down toward the min, which is out of view right now, and then ends up at its starting point. Where do we see that in our data? More than likely, we could see a sine wave here, starting halfway between the beginning of the ride and the maximum point of the first revolution, and it ends right about here. So our sine function begins right about here. What is that point? We know that one cycle lasts 30 minutes. So at the halfway point, we must reach our maximum, which is at 15 minutes. So halfway between the beginning and that maximum at 15 minutes must be where we are at the start of our sine wave, which is 7.5 minutes. This will be our estimate for the horizontal shift. Now the vertical shift. We start off at 0 meters and reach a height of 135 meters on the London Eye Ferris wheel. The midway point between those two is 67.5. So that will be an estimation for our vertical shift. So let's add those to our trigonometric model. I want to add in my horizontal or phase shift. We said it was 7.5, and since it is shifted to the right, that will be negative 7.5. And it's been shifted up 67.5 units. So that's positive 67.5. Let's see how well we now model the height of a passenger on the London Eye Ferris wheel. As you can see, we've done pretty well. The function goes up to that maximum and then down to the minimum for one complete revolution.